Hello students. Today this video lecture is regarding the working principle of Keil software for microcontroller programming. In order to run any of the ARM programming in the simulator, there are many simulation tools available, of which for the academic purpose this Keil software will help in running of the various ARM programs. Before we start executing the programs, in this lecture I would like to instruct you how to install this Keil software, as this software is the open source and freely available. So let us discuss on the installation process. Here I have installed the Keil software of version 5, the Keil Mu Vision 5. In order to install this package, you need two installers. One is the first installer one that consists of the legacy software that needs to be installed first. First, you need to install the legacy software regarding the Keil, which is a MDK microcontroller development kit. Why you need to install this legacy software? Because once you install the legacy software, whatever the updations which are happened in the version 4 of the Keil will directly install into this legacy software, such that once you install the version 5, it has all the prerequisites which was supposed to have it in version 4. Everything will be available, so that again you don't need to update all the version 5 completely. So in that regard, you need to install this legacy software, as the basic commands would have been supported by this version 4. Once you do the installation 1, now download the installation 2 that consists of the Keil version 5. Install it completely by giving some credentials. It will ask you certain credentials. Just give that, maybe your username, the password, or email ID, like that, in order to authenticate you. It asks for updates, which you can skip as of not needed now. Okay. After both installation software, it is ready to work. Once the installation 1 and 2 is done, it is ready for you to work on the system. So once the Keil software is installed, you can see this particular icon on your desktop screen. Okay, it creates a shortcut, and this indicates that your complete Microvision Keil software is installed. So once you double click this icon, you will enter into the IDE, which is the development environment where you can work with the programs. Okay, so you will get this particular mode once you double click the. Now let us start working on the project. So before you do the program, you have to create a Microvision project. Okay, for each program you are supposed to follow this procedure. So where you need to create a Microvision project. For that, in the menu bar, go to project, select new vision project. Once you select it, it will ask you where that particular project need to be stored in your. Okay, you can choose any of the locations of your choice, or you can create a new folder by name microcontroller, and you can dump that, and you can give the file name as required. Okay, this is your project name. Okay, then you can it will be saved as a project files. Okay, you can give your own project name. Okay, and the location wherever you want, and please note which location you are storing the this particular project file. Once you done it, save it. So once you save when you save this particular project, it will ask you in which format it need to be get saved. For that, it will ask you this, select the target where you need to, because since I am working on the ARM programming, so only software pack means it will link only the version 5, but I need to change that software pack to legacy device control database. It is a Dropbox actually. If you just click here, you will get the legacy. You have to select that legacy such that you will get the list of all the other components. Okay, here you have to, since we are using this Keil software in order to write an ARM programming for a 32-bit concepts. So I'm going to select with the ARM, and we have an concept called LPC 2148. See, you are supposed to select this LPC 2148 because this is the mode, or this is the uh, software where it is used to perform a 32-bit RISC concept. There's ARM programming, which consists of all the supporting components available with that. So all the ARM programming has to be written with this particular project. So you have to do this. You have to do all this activity for all the each and every simple program we are doing in a ARM using Keil software. So once you select it, press OK. It will ask you whether you need to copy the file from the any folder or not. Just select no. Okay, because you are writing the program into this mode. Now, if at all you want to inherit a stored project, then you can say yes. So better say no, because please learn by typing the program. Now, you have to suppose to write the program. So go to file and click new. Once you click new, it will ask you the new page text file gets opened up here. Now you can write a program here. So I'm writing a simple program where I'm dumping the data to two different registers and adding these to R0 and R1, and the result I'm storing it to R3. This program is to add two data from the various two registers and dump the result into the another register. Okay, so for this I'm writing the program. So if you can see this is the start. You can see this entry. This portion is the start of each line. From here you have to give one tab and write the program area. So this is the area, indicates in the area you are writing an assembly programming. The program name or a program indicate a program, and it is only key code, and you are reading only. You are not editing anything here. You are reading it. Okay. Now, so for that, since it is a it's a indentation, you have to since you are supposed to maintain a proper indentation for this type of keywords, you are supposed to give a tab. Whereas this entry and stop, you should not give any gap here. You have to start it immediately. So otherwise it gives you an error, because to indicate it as a keywords. Entry is to indicate that you are entering into the this is a label, you are entering into the entry concepts of the program. So move, which is a mnemonic or is a key layer instruction, you are moving a 32-bit. So 0 into 78 is a 32-bit data you are moving into R0. Similarly, 32-bit data, which is 21, is moving into the register R1, R0 and R1. So now add R3, R1, R0. So what happens? These two are the source registers. You're adding these two, and the result what you obtain will be dumped into the register R3. So R0 will be 78, R1 will be 21. After the execution of this instruction, it gives you R3 as 99. 8197299 will happen. So stop B stop. So it's again a label to indicate that the cursor or an instruction pointer, once it has to notice where it has to stop. So before the stop, it has to put into one loop. Stop B stop. So it will go into one loop, then comes for end. Otherwise, instruction pointer because as soon as it gets end, it cannot identify what end is, and it will not terminate. So in order to, for that, you have to put them into one particular loop, such that any loop, you can say LBL. So B means branch, so LBL, stop B stop, or LBL, whatever it is convenient. You can put it up so that it will be in a single loop, and after it, if it finds end, it says okay, it need to terminate, because it's a keyword. So these are all, it needs a label to indicate the stop. Okay, for that I am doing this activity here. So this is the simple program which is written here. Now you are supposed to link this program. I have just written this program in a file. I have to link this program into my project. So you have to save it. Okay, save the project. Just go to file, save. save the project, save the file where the project earlier which you had saved in the same folder. It will ask you directly the same folder, but you should be knowing that wherever the project file was saved earlier in the same place or the same folder, you are supposed to save this program file. And remember that file name should be the file name dot s extension. It should be dot s. As for example, I have given test as a file name. Dot s is a simulator, so it should be saved as dot s. File name dot s, and it should be all files. Save type as all files. This you should remember very clearly. You can give any of your own file name, but it should be of the extension dot s. So once you save it, it will change the color. You can see that it's all in a black color now. Once you save it as a simulator file, it will change the color into it. So area, code, read only, these are all the keywords. Okay. Whereas entry and stop, they are the labels to indicate that. So you can see the data is in red color and registers are all in green color. You can check out these colors. Okay. Now, once the program is ready, you are supposed to link this file to your project. So what happens? Go to project, open in Windows Explorer. You can see this. If you just expand it, you will get a target. If you did expand it, you will get a source group. For this source group, you are supposed to link this test file. Okay. So for that, right click on the source group, add existing file. So add existing files to group. So it will ask you from where. So it will give you the locality. There you select the test.s. This is your file name. If you click that, that get added up to your project. So now this entire program or a text file is linked into your project file. Now you are supposed to compile this program. So there is no keyword by compile. There is a keyword called build target. So go to project, build the target. Click on build target. So it will compile the entire program and gives you the result. So if there are any errors, it will point to what error is and which line, or if it is a warning, it will, since I have written a very simple program here, and so there is no errors and no warnings. So my compiled program is correct. Okay, so no errors. Now, once you compile the program, you are supposed to run the program in order to see the output of it. So for that, go to debug, then say start. So start. So it starts running. It will start from this line and it will stop. It will come to the end. Now you have to stop it. Okay, it will ask you whether 32-bit is. Say okay. Now it will open this particular mode when you start it. So this is the mode where you can see whatever the program you have written that has been converted into the machine language. So it is not up to your level, but you should be knowing how this procedure happens. So there is a small conversion tool which you can use, or a manual which you can refer it, how this high level language which is written by you converts into the machine language. So you don't need to code it here, it is just you. And this block is the register set. You can see from R0 to R15. You can use R0 to R14 for storing of data, but you cannot touch R15 as R15 is for program control. So totally R0 to R15, totally there are 16 registers, of which you can use only 15 registers. This is the command mode where you can see the, suppose if you want to access any memory, then you go to view, then memory 2. Memory 1 is already used by your system, so go to memory 2. When you click memory 2, you can see the memory space here. Since this program I am not using any of the memory associated concepts, so there is no memory concepts here. So run the program. Now go to debug, run. So it will starts running. Now stop the program, because once it runs the program, it keeps on running, because as assembly level language is written for a machine level concepts, so you are supposed to forcefully stop it, otherwise the backend programs keeps running. So you stop it, the command will come to the end of the program. You can stop it. No time limit as it runs faster. Okay, but better give 1 or 2 minutes, maybe 1 minute. Okay. Now your cursor executed, and you can see instruction pointer has reached this point. Now earlier, if you see, your register sets are zeros because it has not run. Now once you run the program and stop, you can see R0 is dumped by data 78, R1 is dumped by data 21, and R3 after adding it, it has dumped the value 99. So it is completely executed. This is how you see the execution, or else you can even see step by step debug step means, so by pressing F11 you can see how each line now is this and how each line executes step by step. Since I have run it one shot, so it is showing me this results. So this, once you have done this, your data is executed. Okay, this is how we use the Keil software to run any of the programs through registers. So in the next video, I'll be explaining how to access with the memory. So I hope this video was clear, and this procedure you have to repeat, you have to follow for each and every simple to complex program which you are running a microcontroller program on a Keil software. I hope this has explained you well. Okay, thank you.